I'm going to continue with another example of how to find the domain of a function. In this case here, I'm going to do a case with roots with factors inside here. I'm going to start with this f of x here, which is the square root of x squared plus 14 times x plus 33. And the thing here is every time we have an expression such as this one inside the root, we have to make sure that we have to factor out what's inside the root. So that's what I'm going to do here in the first step. This x squared plus 14 times x plus 33 could be split like this. X plus 11 times x plus 3. Like that. Yeah. Doing so, we have already fallen into this case that is actually the title of this example, roots with factor inside. And here I'm going to proceed here now. As this is a root, we have to make sure that what's inside the root here, it has to be greater or equal than 0. So I'm going to write it in here. X plus 11, this is the first factor, times x plus 3. This has to be greater or equal than 0. Now, I'm going to do here the full process, how to solve this out. And from here on, what you have to do is you have to pick what's in here, inside this factor. You could take it completely apart. It would be x plus 11. You have to equalize it to 0, and you have to do the same with the other factor. X plus 3 equal to 0. And now you have to solve both x's. Here on the left, I'm going to subtract 11 on both sides of the equation. Here as well, I'm going to subtract 3 in both sides of the equation. I'm going to get here to x equal to 11 and x equal to negative 11 and x equal to negative 3. Now what we have to do here, we have to pick these two values and place it on here on the nice line I've drawn here on the right side. It goes from negative infinite to positive infinite, and it represents all the possible values for the real numbers. So I'm going to place here the negative 11, and I'm going to place here the negative 3. It doesn't have to be precise, a super precise thing. Now here comes the thing. I have to pick a value. It will be between negative 11 and negative infinite and 11, that is to say a value that falls into this interval. I have to do the same for the values between negative 11 and negative 3. I have to pick one, and I have to do the same from negative 11 to infinite. So here the thing would be just to pick the simplest cases. I'm just saying here I'm going to pick x equal to negative 20. Here in the middle I'm going to pick x equal to, I don't know, negative 5. And on the right I'm going to pick x equal to 0 here. Now, what I'm going to do here, I'm going to substitute each of these values in here, in this inequality here. And I'm going to check if each of them passes this test of the greater or equal. So I'm going to write it in here. It will be, here's the first factor. It has to be greater or equal than 0. It's a positive 3. Positive 11. I'm going to substitute there each value. I'm going to start with the negative 20 here. Negative 20, negative 20. And here we get, this would be a negative 9 times here the negative 17, greater or equal than 0. Now, here the thing is, the only thing we have to be really concerned about is actually the signs of the numbers. The signs of the numbers. I'm going to write it like this so you can see it's going to be a negative times another negative. So in any case, every time you multiply a negative number times a negative number, you always get a positive number in return. So in this case, a positive number will always be greater or equal than 0. So in other words, this interval passes this inequality through. Or now that we know that we have, I'm going to explain a bit further this. Basically, what I'm saying here that any number that you pick between negative infinite and negative 11 will always have as a result well, if you substitute it in here, it will always get as a result a positive number. So this will always pass this greater or equal than 0 test. So in other words, we can include all this interval here from negative infinity to negative 11. So every value that you pick from here will produce at the end a positive value substituted in here. Now let's do the same with the other values here, the x equal to negative 5 and equal to 0, and let's see what we find here. I'm going to place here my two factors again, greater or equal than 0, and this will be here a positive 11, positive 2. I'm going to do this a bit quicker here. Maybe here negative 5, I'm going to substitute on the x's. And let's see, we get here, this is a positive 6 result, this is negative 5 plus 11. Here negative 5 plus 3 would be a negative 2. And the question is, I'm just going to pick the signs as well. Here's a positive, here's a negative, and here comes the question. If you multiply a positive times a negative number, you will always get as a result a negative number. That is to say that if you ask a negative number, is it greater or equal than 0? No, it's not. These two guys here will fail this test here. So that is to say, any number that you pick between negative 11 and negative 3 will always produce, substituted in this expression, a negative number that will produce inside the root here, in the original root here, will produce an imaginary number. So in terms of the graph we have here, we do not color out this interval here. We leave it just like that. So now I'm going to continue with the last value, x equal to 0. I'm going to write in here the factors. It's plus 11, plus 3. Here I'm going to substitute 0. This is pretty obvious, but I'm just going to do it still because I think it's better for the purpose of explaining this topic. We'll be here at 11, at 3. Is this greater or equal to 0? Well, actually it is a positive number times a positive number. I'm sorry, here. Positive number times a positive number will always pass this greater or equal test here. So any number that you pick here from the negative 3 to positive infinite will always get as a result a positive number. So we include this interval here. By including, when I say including, it is to say here in the graph we color this out here, this all interval here. Now here, that will be in a way but I think it's not good enough for the purpose of explaining this topic. I'm just going to repeat this test with the numbers we have here, with the negative 11 and then negative 3, just to see what happens here. I'm going to do it here below. Here are the factors, or equal than 0. I'm going to do it just right here as well. Leave a space for the negative 3. Here we have a positive 11, our positive 3, we have positive 11, positive 3. I'm going to substitute both values here. It will be here negative 11, negative 11, negative 3, and the negative 3 here. Now let's see what happened here. This factor here will turn into a 0. 11 minus negative 11 plus 11 will turn to a 0. Here we have negative 8. And here the thing is, this will result into a 0. 0 times negative 8 will be 0. And the question is here, 0 is greater or equal than 0? Yes, it is, because it's equal than 0. So this one passes the test. In other words, this negative 11 has to be included in the graph here. In order to sign this out, we have to use this full circle. We color out this full circle. And I guess you can pretty much imagine what would happen with a negative 3. Because here we have a result, a positive 8, this negative 3 plus 11, and negative 3 times plus 3 will get us a 0 in return. So 8 times 0 will get us here again to 0. Is 0 greater or equal than 0? Well, again, yes it is. It falls into the equal part here of this expression, this here. So it's okay, this interval here. In other words, we have to include this -3, and we include it again by coloring out this number here. Now, from here, what's the only thing left would be just to write down our solution. I'm going to write it in here down the left. We have to write the domain, actually. Domain of f here. We have to basically look at the graph and include what we have already included by drawing here. It would be from -∞, from here to -11. We've written just like this, -11. We include the -11 using brackets here. The brackets symbolize that we are including this -11, and we use a union operation here in order to include the other interval, which is the one after from 3 to infinite. We use the bracket again because we included -3, and to infinite. We close it in here, and that will be basically all.